What's going on, fellas? This video is for a new friend of mine by the name of Martin from New Zealand, I believe. These guys, him and Darryn, or is it Darryn? I'm not sure how to pronounce that name, guy. I apologize. These guys are building a wood drying kiln, and they have asked me to help them on the build that's been commissioned. I believe it is their wood drying kiln that they're trying to build, and they have asked me for some advice on some waste oil burners that I think that would be compatible with this idea that they have, or this plan that they have. So fellas, this is what I got for you. I've got some great advice and some good ideas, and I just want to use this as a jumping off point to determine which direction our plans are going to take. So let me show you what I've got and what I've come up with. Okay guys, now I know you have contacted me in hopes of some help regarding waste oil burners, but after looking at these pictures you've sent me, the question begs, why have we not considered to commission a build that utilizes some of this wood as a heat source versus waste oil? We could just as easily do that with a device similar to what I'm about to show you here. This is a device I built years ago that is basically running off wood and compressed air. Sorry about that ad. Something like this might be suitable for your idea or your plans. I also have several other videos of this device to kind of show you what it looks like. Well, this one has leaves in it, but it's similar to this, except it would have wood inside of it. It can definitely produce a significant amount of heat. It's a cyclone combustion chamber. Now, if you were to fill this with these large chunks of wood that I'm seeing here, you would create an extremely powerful burner that is definitely capable of producing the 115 to 140 degrees Celsius temperature that we're aiming for in the kiln. So I want you guys to chew on that for a minute and think about the idea of possibly using a cyclone combustion setup. Let me see if I can find a better version of this thing running for you guys. Here we go. Check this out. I will leave a link in the description for this video. This is a device that I built many years ago. As you can see, the date is 2012, so about 6 years anyway. And something like this can run for hours on chunks of wood like this. Eventually, after all the tars are boiled out of the wood, it goes down to an extremely fire-hot carbon fire. So I want you guys to think about the possibility of changing your mind and using wood instead of waste oil, because waste oil is, you're gonna burn barrels and barrels and barrels of this stuff, trust me. Okay fellas, here is one idea that I have for you that I suggest that would eliminate the smell problem that we talked about, or at least that I've mentioned. Now, one thing that I do recommend you guys do is build some type of fence on top of the shipping containers and throw a bunch of rocks and dirt on top of the shipping container. I would also mound piles of dirt up against the walls of the shipping container to act as an insulation, because you'd be surprised at how much energy we can conserve by just burying this thing in dirt. And even if you would be willing to bury the thing entirely in dirt, that'd be some pretty cheap free insulation, you know. So that's something to think about. My next proposal is that we dig a trench underground. Let me give you a cross-section view of what I have in mind here. If this is the shipping container and this is the ground, I recommend cutting a small channel underneath the shipping container and then putting some steel sheet down to block it off, and have one central hole on one side that blasts fire down that hole, or maybe just the heat from a waste oil burner that's completely enclosed so as not to overheat a certain zone. But I suggest blasting heat through the bottom of the shipping containers where the smoke and the fire is never in contact with the wood inside of your kiln, and yet we still have tremendous amount of heat emanating up from the floor. At which point we would use that blower that you said you purchased to blow air directly on this hot zone from the waste oil burner, and the air would then be retrieved from up above, taken into the blower and recirculated inside the shipping container. No fresh air is going to be added into this. We do want to have a small weep hole of some kind, some type of special calibrated vent that will let the moisture from the wood out. It's going to have to leak a little bit. The doors and all of that will probably provide enough leak to let the moisture emanate. But for the most part, we're going to want this blower to simply circulate the hot air so that you don't have hot zones. And I believe that you guys could probably calibrate fairly easily what it's going to take to hit the 115 to 140 Celsius that your kiln's going to want to operate at. That is some of the figures that I have come across in my little bit of research, and I want you guys to think about what I have here as far as the construction of the actual kiln itself. I do not advise blasting straight waste oil combustion gases into this chamber. That's going to smell horrible. After running one of these devices for just an hour, my garage will smell for several days. So it has a sticking, lingering odor that may not be something your customers are willing to tolerate. So I advised we go with the the channel underneath the unit and just let convection, and as I said, we'll aim your little blower hose directly over the hot spot. I recommend placing the blower off the side of the unit somewhere so it's not exposed. The motor itself isn't exposed to all that heat. So you would have the discharge of the blower and then have the intake of the blower come from somewhere farther away from this area, preferably on the exact opposite of the super hot zone. And I think that blower would really serve you guys well, blowing that air around in there and keeping those hot spots down. Because if we get really hot spots, what's going to happen is the wood is going to start to gasify, and it will leach out tars and start to smoke. You guys know what'll happen. I'm sure you're well advised in what could take place. So the blower you bought is going to work excellent to blow on this hot spot where we have a single waste oil burner. I want to show you the burner I have in mind for you. Now, you question this device here. I do not recommend this device at all. This is the one that has a vacuum cleaner motor that hooks up to it. I'll put a link in the description for that video for people who are interested. The blower motor came out of one of these little tiny shop vacs. It cost 20 bucks. And for that $20, you get a fairly decent little blower that I have completely lost. Here it is. You have to do some modification. You see all the discharge vents I have soldered closed with acid core solder, but this does have its own cooling fan on it, which is absolutely essential. If you're going to salvage one of these out of a vacuum cleaner or something, typically the blower air is used to cool the motor, and that will not work. You're going to want something that has its own independent blower on it. However, as I said, the reason I don't recommend this type of combustion chamber is because its operating time is very limited. Eventually, slag and deposits will build up inside of this thing and will render enough heat shielding that it will no longer vaporize the oil. All that buildup will stop that oil from hitting the hot exterior of the combustion liner there, and that's what vaporizes the oil on these things, is the combustor itself getting hot. If this liner doesn't stay hot, the device will fail, it will burn out. And the device I recommend is something similar to this. You do not need all this fancy stuff that I have put on here. This is a high performance device that burns absolutely almost all of the oil. The flame's only this big. Without it, it's a fairly large feathery flame. But something like this
will run indefinitely. The buildup is blasted away by the jet. Now this device runs on approximately, I think it was 127 liters per minute. It's 6.5 bar. At that rate, this thing cranks out about 40,000 watts of power. Anywhere from 40 to 60. I'd have to double check the nozzle I've been using. But it's probably hot enough to keep a chamber that size at the temperatures you're looking for. In my opinion, it might even be too hot. But this is the design you're going to want to go with. It is the simplest, and some research that I have done in the past has suggested that you could simply cut a hole in the top of a pipe and it will work. So you could take a piece of pipe, you know, somewhat smaller than this, I recommend. You showed me a piece that you have that looks like this. You could probably just cut a small hole in this pipe and aim your waste oil burner nozzle at an angle in there to get that swirl effect. And it should act as a good waste oil burner. You can't just place the nozzle in there like this, because it acts as an air pump and it just blows the flame right out the barrel. That is why I designed this little bad boy right here. I'll also place a link in the description for this device. Now, the operating mechanism behind the stability in this thing's combustion comes from a swirling fireball that is induced by the interior design of this combustor. The jet is hitting a circular ramp that causes a vortex of fire. That vortex of fire keeps the device ignited so that the flame isn't simply blasted out the other side, which is what happens on short straight bore pipes. Now there are people who have videos on very long pipes, but those things are extremely loud. They resonate sometimes. They are incredibly loud devices. They're basically pulse jet engines. These things too are also kind of loud. They're running at about 100 decibels. So you're going to hear the thing running, that's for sure. However, I think it'd be simple enough for you guys to find a piece of elbow. You're looking at about $14 worth of parts right here. This thing's not going to last forever, but because it's so cheap, you should be okay. This casing is eventually going to just burn away. I don't have the information on how long it will last, but I will show you some of the specifications of its construction. Okay guys, these specifications were the sweet spot for the device that I built. Now of course that may change depending on your nozzle, but my nozzle tilt was 41 degrees. The apex of this transition was 17 millimeters out from the face, and my pulse jet buffer plate was 21 millimeters from the edge of this hole. If you don't have this plate, a lot of pulse jet effect takes place and fouls up the nozzle, and I believe it might even get the nozzle a little too hot. So these are the exact specifications of that design that we just looked at. Now you could vary this. I mean, I have built with the same nozzle devices as small as this. So you can go from this small up to this size, no problem at all. Now, I know you were thinking about running a system on an air blower, but as I said, I don't recommend it because that would require the use of a Delavan nozzle. The problem is Delavan nozzles don't burn waste oil, so don't do it. I don't recommend it. Now, I know you were worried about running an air compressor, but I want to tell you something about these things. As a carpenter, I can tell you that these things will run for 8 to 10 hours a day, 6 days a week, for up to 2 years without failing. You can convert one of these into an oil tank as well if you needed to, but we're not going to worry about that. For the most part, these things pump oil themselves. This nozzle produces a Venturi effect. I'll place a link in the description that shows how I built this nozzle, and this thing pumps oil on its own. You don't need an oil pump. The air pressure alone pumps the oil. This device you're looking at right here can put out 40,000 watts of heating power. This tiny little thing. The problem is it's not made out of stainless steel and probably wouldn't last longer than a couple of weeks if it was run every day at that rate. But this is another option you guys have. This is an extruded combustion chamber. And let me show you the features of that. There's not really much to show you as far as specs go on this one. Sorry, I'm not ready. It just basically looks like this inside. It has a little scoop. It causes that vortex of flame there. This is what enables combustion stability. It is a very important parameter in the design feature. That you take this out of the design and you might just leave it a straight pipe, it will not run. It's just an extruded piece of metal. So if you can come across some stainless steel plates, man, I wish you guys lived by me. I'd just build a burner for you. But some stainless steel plates like this would be very suitable for building an extruded combustor design. This stuff's toxic to work with, so bear that in mind. If you never work with stainless, it's very toxic to work with, grinding it and welding it alike. So, and that's what this thing is. I've named this design the Little Dragon because of its ferocity. This thing is incredible. I'm going to be doing a lot of work with this thing in the future, but I'm going to end this video for now, fellas, and let you digest some of the information I provided. As I said, I strongly recommend you use a compressor-driven system. This thing does not run continuous, by the way, at the rate I've described. At 90 PSIs or at 6.5 bar, it's intermittent. It doesn't run the whole time. So this is what you guys are going to want to build right here. I'd give you this one for free, but it'd probably cost me $250 to ship it to you. If you guys would be interested in seeing what the shipping would cost, I could just cut this thing off right here. Well, you can make this yourself. I don't know what I'm talking about. It's as easy as pie. A drunk monkey could do it. I got faith in you guys. So this is what you're going to want to do, and this is how I run it. I converted this three-way adapter. That's how I connect my air line and convert it over to this to control my air input to my siphon nozzle. That's how I get air into the siphon nozzle. And that's the oil input. Now you can change the oil input by simply raising the elevation of the oil canister. Just by lifting it up in the air and setting it up high will increase the flow rate of the nozzle. You might want to put a secondary valve on there, but for the most part, guys, these burners right here, they foul up. They're only going to run for a day at most before you got to take the thing apart and clean it out. I highly recommend you do something like this. And by the way, I forgot to tell you, if you do build one of these, you're going to run it like this. That's upside down. I don't know why I drew it like that. It needs to be run like this or on its side. If you don't, I don't know what might happen as far as accumulation down here. We may get some stuff, some crud stuck down inside of there. I don't like the idea of leaving it like this because oil will often puddle. Hard telling what can happen. It's a bad move. You would want to go sideways or like this. So, yeah, I'm not an artist. I apologize. And that's what we got, fellas. I also wanted to share with you another idea. In the event you would need to pump oil, you can do something like this where you convert your air compressor into an oil pump as well. You just need to add a fill cap, connector to the bottom, and a T-valve. That way you can run the nozzle and you can pump oil at the same time using a compressor. I've done that right here with this guy right here. I subsequently decided that this secondary air tank is unnecessary. Merely adding a connector to the bottom of the compressor would have sufficed. So it was an afterthought that I could have done that. Sometimes I make really dumb moves like that. I recommend a valve for your fill cap. It's just more convenient rather than something you got to keep screwing off and on because you got to put thread tape on it every time. This right here is just a quick bam, you're done and over with. So if you did decide to do the oil pump idea, because these siphon nozzles, sometimes in the winter, I don't know how cold it's going to be when you guys are going to run in your guys' device, you might need a little oil pressure on that. This tank right here, this 8-gallon tank, would run for 8 hours at about 40,000 watts. Which, like I said, that just seems like too much. We don't want to turn the wood into charcoal. We're just drying it out. So we need to figure out how big of a flame. Okay, I know this is painfully obvious, but in the event that it isn't, we would, of course, dig the trench and then use the tractors to drag the containers over the top of them. Surely you guys knew that right away when I showed you that. I didn't want you to think I had some dumb idea to bore a tunnel underneath the containers. No, I think we should dig a trench and then drag the containers in position over the trench that you dug. So that's my 2 cents on that.
So fellas, that's what I got. It is hotter than fire out here. I got to get out of this garage, man. So I'm going to come up with some more information to shoot at you guys, digest all that rambling a little bit, tell me what you think, and I'll get back with you